All right, I make that about 2 minutes past the hour. Thank you all very much for joining today. We're going to be talking about CockroachDB, distributed SQL, and we'll give you an introduction to CockroachDB on AWS. I'm your co-host, Rob Reid. I'm the company's technical evangelist. And today I'm joined by the very wonderful David Joy. David, thank you for joining.
Thank you, Rob. Thanks for having me. Excited to talk to this audience.
So today is going to be a not necessarily a deep dive, but we're going to be talking about a bunch of things. If you have any questions at any point, just feel free to put them in the Q&A. I think the chat is probably locked, but put them in the Q&A. David and I will get to them as quickly as we can. There'll also be a survey after the webinar. So if you can take the time to fill the survey out, that will help make all of our future webinars better. So I'll start with a brief history of databases, explaining where we are now and how we got here. So everything starts back in 1970, about 55 years ago now, with the advent of relational databases and the term relational database. So Oracle, DB2, Sybase, databases like this were the pioneers of SQL, and they are a big proponent to the reason we exist as we do today, and they've helped shaped the landscape that has made for distributed SQL. Skip a few decades ahead, and we reach the era of NoSQL databases. These databases were the pioneers of data at scale. So Cassandra at Facebook, Elasticsearch, MongoDB, everything then started really in earnest in 2008, but the term was coined way before then. Skip ahead a little bit further, and we reach the era of cloud databases. These are essentially the traditional databases, just hosted in the cloud. Then we had, in 2012, the white paper for distributed SQL from Google, and that explained what a distributed SQL database should and could be. And that's what really kicked things off. We released in 2016 and were shortly followed by Google's own Cloud Spanner. So to summarize what CockroachDB is, it's melding the best of all worlds. There are the benefits of durability, consistency, and isolation with the familiar syntax that you're used to from a relational database, with the horizontal scaling of NoSQL databases. You can deploy us anywhere, including the cloud, AWS, and the other clouds, but you can also deploy us on-prem. It really doesn't matter. So we've covered the when, but in order for the what and the how to make sense, we'll have to cover the why now. So I'll talk about why distributed SQL specifically. So what we have here is a monolithic database on the left and a distributed SQL database on the right. And this isn't a sharded monolithic database. This is a horizontally scalable distributed SQL database on the right. On the left, a monolithic database or any cloud service provider database that offers you a single writer instance acts as a sort of single point of failure. And they are susceptible to networking, power, large scale regional kind of outages. And at this point, you're in the world of disaster recovery, usually via backups and restore, or maybe primary standby failover type kind of scenarios, but they necessitate that a failure must have occurred in the first place. So you're looking at having reasonably high RTO and pretty high RPO as well. We'll cover that in a minute, and I'll explain what those are. Then we have the distributed SQL databases. When there are multiple nodes that make up your database, and each one is physically distributed from one another, perhaps in a different region or availability zone, or at least a machine, there are still benefits at that level as well. You don't have a single point of failure. So you can survive lots of different types of failures, including network failures, certainly power failures, and the like. And this is more of a disaster prevention world. You don't have to wait for a disaster to happen and recover from. The database is self-healing and preventing disasters from taking your business offline. That offers, in this world, we're looking at 0 RPO, that's data loss, and very, very low to minimal RTO, that's essentially downtime. So let's look at RPO and RTO. This is the RPO and RTO of a traditional database. And across the x-axis, we have time. And all the while, we're running our workload, we're making backups, as any sensible database practitioner should be doing. Now, at some point, we'll make our last backup. Now, this isn't downtime. With the business is still ongoing. Everything's fine and dandy at this point, up to the point of an event. And let's assume this is a disk corruption event, for example. Everything that happened between the last backup and the disk corruption event is lost data. That's the RPO. That data is not necessarily going to be recoverable because it hasn't been backed up. Everything from the event right up to the point of recovery is your RTO. That's a traditional database, but this is what RTO and RPO look like in CockroachDB. Along the x-axis, we still have time, and we're still making backups. We don't recommend you stop doing backups just because you're running a distributed SQL database. However, there'll be a point at which you make your last backup. Perhaps you're making 5-minute incremental backups. And then there's an event, a disk corruption event, let's say again. Because data is replicated across multiple machines, we'll dive into that in a minute, there's no data loss. Your data is always guaranteed to be correct, and you're not going to lose any data. And because the nodes are self-healing, downtime becomes a machine speed of effort as opposed to a human having to be paged and manually resolve it themselves. So we're talking about RTOs for CockroachDB averaging around 4.5 seconds at very worst. So let's talk about the tenets of distributed SQL. This is what a distributed SQL database should offer, and then we're going to go dive a little bit deeper into CockroachDB. Firstly, a distributed SQL database should be able to offer you consistency. What you write into the database is exactly what you should expect to get out, regardless of the machine you're talking to, regardless of the application you're writing. Every user of your database should have a consistent view of data at all times. So if you take a payments example or a payments use case, for example, if you get an inconsistent view of data, that's money lost potentially, or medical records are, the wrong medicine is given to the wrong person, audits are failed. This is the kind of thing that might go wrong. Next, the database should be resilient. You should be able to survive machine, data center, network failures without your database going offline, with zero data loss and no loss of data integrity or consistency. It should be natively distributed. Having machines being able to horizontally scale gives you the option to place those nodes where you need them. And you can define your own read and write latency requirements based on where your users are. So you might think that having a globally distributed instance of CockroachDB might offer slow performance, but there are ways you can tune it to get blazing fast performance for reads and writes for all of your users. And finally, you should be able to scale as you need. You might start on day one with a very small cluster. You shouldn't ever have to over provision your database. And then as your business evolves and grows, you can start scaling up. And eventually you might end up with different numbers of nodes in different places or regions, just to service the different patterns of traffic that each of those regions are providing. And you should be able to elastically scale back down again when that compute is no longer needed. So let's go a little bit deeper into CockroachDB now. I'll start with the absolute fundamentals. The smallest unit of compute in CockroachDB is a node. And all that is a binary file or a Docker image or a Kubernetes pod. And everything in CockroachDB is the same. There's no special master nodes or read replicas. A node is a node. And a cluster of nodes is formed of multiple nodes. And that's all it is. A cluster is a group of interconnected nodes that communicate with one another to self-heal, but they present themselves as a single database. So you would talk to CockroachDB just as you would a single instance of Postgres, but you get the benefits of distribution. And the way we scale is via a mechanism called ranges. Now, if you imagine a table on its side and you cut it up into bits, each one of those bits is by default 512 megabytes in size, similar to 512 megabytes. And that's the default size, and that is a range. And let's say in this example, we've got 3 ranges. Now, obviously, they're not going to contain 2 rows. This might be, a couple of million rows. But everything from vetiver to spice, and it's sorted by the primary key. So if the primary key was named, you'd see these in order, but it's sorted by primary key, which in this case is the ID column. So everything from 0C to 110 is our first range. And that's everything from vetiver to spice. Next, we have patchouli and neroli, 24 to 3D, etc. Each of those ranges is by default replicated 3 times. And that's how we achieve consistency at scale and also the ability to survive outages. So we'll have one replica of range 1, the second one, and the third. They contain the same data. And the number of ranges can be arbitrary from 3. 3 is the minimum, but you can arbitrarily go higher at the cost of write latency. And let's take a look at how these are distributed then. In a 5-node cluster, our ranges might be distributed like this. So we've got replica 1 of range 1, replica 2 of range 1, and replica 3 of range 1. They might be on these nodes. Not every node needs to know about every replica or range. A question I get asked occasionally is, if I have a 100-node cluster, do all the nodes need to know about the data? Do I have 100 copies of data? No, you don't. If that was the case, you wouldn't be able to scale. Then we have 3 replicas of our second range, 3 replicas of our third range, and there'll be other ranges, but obviously these ones aren't part of the example. Now, one of these replicas is special. It's the leaseholder for that range of data. Now, instead of having a single point of write entry to the cluster, CockroachDB has a leaseholder for each of the ranges in the database. And this is what orchestrates reads and writes for a particular range. Now, you don't necessarily have to go to the leaseholder, but you can opt in to slightly stale data to reduce contention, etc. But to all intents and purposes, default workload, you would talk to a leaseholder. So the nodes talk amongst themselves and they elect a leaseholder. So maybe replica 3 for range 2 is the leaseholder. Maybe replica 2 is the leaseholder for range 1, and replica 2 is the leaseholder for range 3. The nodes sort this out themselves, and it's also geographically aware. And this is what a read operation might look like. So we've got a user here. They're talking to CockroachDB via a load balancer. And this is an arbitrary number, 6 nodes in a cluster. Wouldn't necessarily recommend an even number of nodes, but this is the leaseholder, and there are 2 other replicas of that range. So the request comes in, it hits a node in the cluster, and that will be defined by your load balancer. And it happens to have hit node 3. Each node knows where to find data. So it knows that in order to get a transactionally consistent view of the data that they're asking for, they'll have to go to node 4. So the request will be internally routed without your knowledge. You don't need to know about this. This is a database concern. It will fetch the data. It will return it to node 3, and it'll be then returned to the caller. We've just had a question. Where are these talks later published? Would love to consume all the lectures and blogs. So that's a good question. We do have a couple of people online in the chat who might be able to give you a more comprehensive answer than me, but I would imagine we're probably emailing them or something like that. But whoever's listening from Cockroach Labs, if you could follow up, that'd be lovely. So that was read operations. Next, we have write operations. These are a little bit more involved. So let's say our request hits node 3 again. Again, it could be any of the nodes. It will make the write request to the leaseholder because it knows that it should go through the leaseholder in order to achieve a consistent write. And the leaseholder will write this data to its disk and say to the follower replicas, the other replicas of that range, by the way, the user is wanting to make a change, commit this to your write ahead log. And it's actually a raft log. Underneath CockroachDB is raft. Now, the first one that responds, the leaseholder knows that now the data is in 2 places. 2 out of 3 places makes for a majority or a quorum. So we can return the request to the caller to say that your write has been successfully made. That's why having a higher replication factor increases latency slightly because it needs to hear back from more nodes. Asynchronously, after the request has happened, the other node will still say to the leaseholder node, I've also written my data. So it knows it's safe in 3 places, but that's not part of the critical flow. It's just the nearest node. And we've had another question. Or network partitioned node will not entertain any request the moment the cluster determines that the node came out of the cluster. It depends on the network partition type. So you can either have a bidirectional or symmetric network partition or a unidirectional asymmetric network partition. CockroachDB will do its best to route around the network partition on your behalf. But yes, if the node is unreachable, the node will be marked as suspect and eventually unhealthy and then dead. And there's another question. So how to maintain the load balancer? David, if you want to jump in on any of these, feel free as well. I don't want to be hogging.
Yeah, don't worry. I'm actually typing in the responses
Oh,
as we
thank
go.
you.
So I was just getting through all of that. But I think we can come back to some of these questions once you finish the right operation piece as well. So yeah.
Yeah, that sounds good. That sounds good. I'll carry on. But we will get to your questions. Don't worry. The next thing I'd like to show you is our performance under adversity benchmark. So a while ago, we were thinking about performance and resilience. And there's a lot of database benchmarks. Indeed, there are lots of software benchmarks that focus very intently on performance, and they don't take a holistic view of what performance means at a greater scale. I like to think that the performance of a database matters less if that database is down. So resilience becomes incredibly an important part of your infrastructure, especially with the advent of agentic AI. But the raw performance of a database still does matter. So what our performance under adversity benchmark does is it's a 10-hour benchmark running across multiple nodes with a TPCC, which is just a simulation of an e-commerce warehouse-based workflow. And it's a fairly small workload. We're making about 25,000 queries per second. And that equates to about 80,000 transactions per minute, each of which has about 9 requests. And we test baseline performance for this workload. So this is blue sky, happy sailing workload with no adverse conditions. Then we do what no other benchmark is doing. We perform different phases of increasingly severe operational stress. So the first is internal operational stress, and we run a full database backup just to see what the impact on the database is. And the blue line down here is the database throughput. This is the workload that's running, and you can see any impacts on the throughput of that workload given throughout the course of this test. Down here, we have the baseline latency, which the P95 is around 21.5 milliseconds. Then we start a change feed. CockroachDB has built-in change data capture, or CDC. So we start a change feed and measure its impact on the workload, and there is little to none. Next, we create an index. So we perform an online schema change. Schema changes, database changes like that are performed online, so you can do them intraday while your team are available. And that's the start and finish of that. Then we perform an entire database upgrade. So we upgrade from one version to another. There are 15 nodes. There are 17 dots. The first dot is the start. These dots represent the nodes being taken out of the cluster, upgraded and put back in. And that's the end. Then things get a little bit nastier. So when I talk to customers and prospects, some of the things that worry them the most are the gray failures. Not necessarily a node going offline, because that's an immediate failure. Your users will immediately recognize something's wrong, as hopefully will your monitoring systems. Disk stalls and network failures are gray failures. They don't necessarily make a bump in the night, but they do degrade your service. And we perform 50 disk stalls, one after another, each lasting 10 seconds. So we stall the disks, and these are frighteningly common in cloud environments. If you're running elastic block attached storage, disk stalls are happening all the time. So we perform 50 disk stalls and measure the impact on throughput. Then we create a symmetric and an asymmetric network partition between the nodes, not all of the nodes, some of the nodes, just to measure that impact. Then we start killing nodes. So we kill 3 nodes at random and completely take them out of the cluster. And then finally, because this is a multi-region installation of CockroachDB, we take out an entire availability zone, which comprises 3 nodes. And if that wasn't bad enough, we then take out a whole region, which comprises 5 nodes. And we measure the impact. So instead of traffic dropping to zero, which it would with a traditional database, in fact, many of these issues would result in complete downtime. We see slightly increased latency. Now, what I haven't shared yet is this is running on CockroachDB version 25.1, which is a couple of versions behind the latest version of CockroachDB. If I switch to that, you'll see that this blue line, this line of database throughput, essentially what your users are experiencing of your application is incredibly flat, even when it comes to entire regional outages. Not only that, but because we appreciate that database baseline performance still matters, we've reduced the P95 latency from around 21.5 milliseconds to 2.5 milliseconds. And the very worst case scenario, a entire availability zone region going out. Let's imagine what happened a couple of weeks ago. In fact, all of the cloud providers, have run into these things. Their environments are not infallible. We saw 38 milliseconds of additional request latency. So yes, that was performance under adversity. And the last thing I'll share before handing over to David is the fact that it's a monumental challenge to develop any distributed system, let alone a distributed database system. But it looks easy. Obviously, you want a system that makes your lives easier. And when the state of your resilience means that you can offer very smooth performance for all of your customers, that's ideally what you want. We were curious and tested our performance under adversity benchmark against one of our distributed SQL peers. I won't say who. We're not in the business of dragging people's names through the mud, but you can see just how complicated a challenge this is. We ran exactly the same tests over exactly the same period of time, and the throughput is all over the place, as is the latency. We're looking at well above a second or two in latency. It's actually off the chart here. But the workload is very badly impacted. So that was performance under adversity. Again, if you have any questions on this or anything I've mentioned up to this point, let us know.
Yeah. And I can just jump in here. And there was a few themes that I noticed when you were talking and in the questions, Rob. And most of them were around, failures that they see with databases and how do we handle it, and also the context related to how it works in the context of load balancer, right? And I think what Rob covered essentially is to give you a picture of what it is like to run CockroachDB in production, right? A typical database, when you run, the ideal state is that early stage that you see in this chart, which is early baseline green, which is what everybody wants. But in production, we see a bunch of different events and scenarios happen. I think somebody, asked the question around, network partitions and things like that. Shashi, you had asked that question. And these are situations that happen. But the way CockroachDB is designed, because we are an active system and has built-in consensus into the system across the replicas, we make sure that even when these kind of incidents happen, scenarios like distalls or network partition issues, network failures, Cockroach will always be able to perform as you want in production. And then there was also a question around point-in-time restore. And Rob, feel free to chime in. We have backups available, change data capture available to help go move data into other sister systems or locations where you want to, keep data in and bring them back in case of a situation. But our ideal objective is to make sure that you never lose data. So we're always on system. We want to make sure that you never lose data and you always have high availability and resilience, right? And that going back to the name of the product, which is CockroachDB, the intent is to make sure that it always survives any kind of scenario. So we do want to make sure that you don't have to go in and do point in time restores or minimize that kind of incident. So that's basically what Cockroach offers. Obviously, there are different deployment patterns available that we'll cover towards the end for you to consider and rethink how you do resiliency. But objectively speaking, I hope you get an idea of how kind of Cockroach works under the hood. Rob, if I missed
Yeah.
anything, feel free to chime in. I'm
Not at
sure,
all. No,
yeah.
that was wonderful. The one thing I would mention, I guess, is I'm guilty of this, and I'm sure many of you are guilty of this as well. I have a history of applying a a resilience strategy called hope, and I've learned over the years that hope is not a strategy, and I think this is our recognition that hope shouldn't be a strategy for you. And I would urge whichever database provider or application provider that you're working with, hold them to account for their resilience, because ultimately you will eventually become accountable for yours, if not to your customers, to those who regulate your business. So the fact that we have regulations in place in the EU, like DORA, the Digital Operational Resilience Act, tells me that if we were doing enough with our traditional databases, we wouldn't have DORA. So something needs to get better.
Absolutely. Right. So let's just continue with a little bit of an high level idea of what a Cockroach looks like on AWS, right? So if Rob, you can go in. So today, if you want to use CockroachDB on AWS, we have an AWS Marketplace integration. AWS is one of our strongest partners. We've been working with them for from since the very beginning. But over the last 4 or 5 years, we have actively worked together with AWS. In fact, we just not just but about a year ago signed a strategic collaboration agreement with AWS to accelerate modernization and Gen AI adoption. So AWS is investing in Cockroach as well, as we work together as partners to help our customers modernize from legacy systems that run on SQL, Oracle, Sybase, Postgres, and that doesn't work out. So all those systems that you are probably using, you can collaborate with AWS and us to help you modernize, and obviously with the Gen AI piece as well. Today, if you want to run on AWS, there are multiple patterns available. We offer multiple ways to kind of run CockroachDB. Categorically, we have two product categories. We have a self-hosted category, which is basically you can get a CockroachDB license and manage it yourself by running it on EC2 instances on AWS or EKS. Or if you are somebody who wants to run it on a region that is not available in the cloud, typically you can use AWS Outpost as well, which is like this big rack instance that you can bring in and put it into your data center and get it to work. And if you don't want to self-manage, you can actually use Cockroach Cloud, which is our own cloud product that has multiple different variations from serverless to an advanced category for you to basically have a fully managed product that we manage, but you can just choose which cloud provider you want to choose, and you can choose AWS. And obviously, for folks, as you can see, we have been working towards this modernization story with AWS. We also want to make sure that you have low friction migrations. So one of the key things that we really take into account is how easy can we make it for you guys to move from your existing database to Cockroach very easily. So we already have integrations with AWS DMS. We work with that team to help you with the data migration using the data migration services. Obviously, we already have a bunch of migration tools that we already built in. We call it Molt, that can be taken advantage of in this migration. We also have a bunch of partners that both AWS and Cockroach have certified to help with these migrations as well. And if you're looking to do, snapshots and backups, and if you want CDC, we actually have, AWS S3 integration. Obviously, Cockroach, as Rob described to you, is a distributed SQL system. And what comes with in a distributed SQL system is to consider how you want to run it. So obviously, you can choose to run it across multiple regions, or you can run it within a single region across multiple availability zones. And Rob, I mean, it wouldn't be I'm pretty sure 99.9 or almost 100% of our customers are running multi-AZ if they are running on cloud, because you kind of lose the point of using CockroachDB if you keep all your nodes in a single region and you want resiliency. However, there are patterns where people might be experimenting in a single region, single availability zone, but typically you do run on AWS across multiple availability zones and multiple regions. Am I right? You want to chime in on that? I'm sure you've kind of recommended that, Rob, to multiple folks. So
I think there are benefits to any distributed system. If you are running across multiple machines, you will reap benefits from that. But it comes down to your risk appetite.
yeah,
If you are worried about a data center going down, then your system needs to be robust against availability zone slash data center outages. It Your deployment topology will be largely dependent on your risk appetite and where your customers are. So there's a lot of flexibility as to how you place nodes, configure your clusters to make sure that you're giving your customers the best experience, but also your engineers the least stressful life you can.
yeah. And I think if you use the hope architecture strategy, which is what I've seen many people do in the past, you will make decisions where you would not consider, these patterns. And we believe that you should consider these patterns, especially in 2025 with the way data is scaling. I think Cockroach is very significant because you do not want outages, right? I mean, 10 years ago, you would have an outage, you wouldn't see a big fit on Twitter or X, or companies losing reputation, because of that. But today, resilience is a table stake conversation happening in the boardroom, and it's really critical.
And
Obviously,
it's also being
yeah,
discussed by consumers. It's forefront in customers' mind. They're waiting for the next major outage to happen.
yes,
They're primed, and I think there's a lot more visibility from the
yeah.
consumer side now about outages.
Absolutely. Yeah. I think I agree with you on that. Yeah. So that's where we are with CockroachDB on AWS. So if you want to get started, if you need cookbooks to get started, please hit us up. Please hit my team up. And Rob, we have cookbooks available to get you started on EKS, on Outpost, as well as with EC2. If you're using Terraform or CloudFormation, we can provide you these cookbooks to get started on AWS. And if you go to the next slide, we when we partner with somebody, we have to consider that you are not running our product in the vacuum. We have to think about the upstream implication and the downstream implication. So actively, our team has worked to basically integrate with multiple key, solutions and products that AWS has. So if you're somebody who's using, for data movement, say S3 for backups, or if you are familiar with MSK, or you need Redshift where you want to like move some data in and do some analytics. If you are interested in IAM that AWS provides, or in fact, with the recent push on GenAI, if you are using Bedrock as your large language model provider, we have integrations with these systems already. So there is a bunch of them over here that you can see, but your experience running Cockroach on AWS will feel like a first party experience. That's the goal, that's the objective that we kind of take seriously as a company, and that's how our integration, our conversations with AWS go. If you go to the next slide, I want to basically talk about a success story that we have had.
Bef-
Do you want to chime in anything before we go there,
Before
Rob?
we
Yeah.
before we do, we've just had a question about alerting and monitoring.
Hmm.
So we talk about the integrations with AWS specifically, but how about alerting and monitoring? So to speak to that, we have built-in support for Prometheus endpoints. So if you're feeding your dashboards with metrics, we have a bunch of metrics right down to query level metrics that we publish from Cockroach. So if you're exporting to Grafana, to Datadog, and the like, you'll be able to integrate there. Have I missed any
No, I
integrations
mean,
there, David?
you could do that. Yeah. I mean, so we also already work with Amazon CloudWatch. So if you want to move these metrics out into your AWS ecosystem based, monitoring solution, you could do that as well. So yeah.
Thank you.
Yeah.
And another question, how can we save real disk consumption? So that's comparing Cockroach against Postgres's vacuum. Now, CockroachDB has its own vacuuming technology built in, and it's essentially our garbage collector. So under the hood, CockroachDB uses the multi-version concurrency control (MVCC) pattern. So if you're making a large table change, CockroachDB will spin up another version of your table, make that change. So there's another version of the table, and once the change is finished, we switch over to the new one. Then the old version of the table is marked for garbage collection, and you can tune the database to clean up data as frequently or as infrequently as you like. We set the default at 5 hours, but you can tune it up to what we regularly test at as 24 hours.
Yeah.
That also allows you to select deleted data in the event that you've accidentally truncated a table, for example. You can still see deleted data from even deleted tables. But that's how we do it. It's not a concern that you have to manage. You don't have to run Postgres vacuums on CockroachDB. They're happening in the background for you, and they are subject to our admission control. So if you've got a very busy hot running cluster, you have confidence that the background job kicking off to continually clean up garbage or old data isn't going to impact your foreground workload.
Yeah, great. Well said, Rob. Yeah. So we have another question. Saw earlier in the year that CockroachDB introduced vector search with transactional data. Do you see the future as a converged database that eventually makes specialized vector stores like Pinecone, or do you see a place where multi-database AI stack exists? So, Rob, I'll let you come in, and I'm
Sure.
sure both of us have different thoughts, but I'll let you
Yeah.
go in first. Yeah.
Sure. So my thoughts on this are there are benefits to all approaches. I don't think there's a silver bullet. By running AI workloads against a relational database, however, you're gaining the ability to run unified queries. So you can run vector searches from within CockroachDB using a distributed index against that vector data, but you can also use SQL intertwined with your vector queries. You can also put your existing data to work for you. If, let's say, you've got terabytes of historical company data that's very useful for you and you want to get more value out of it, you can create vectors that live alongside that data and update with it, that then you can use in your recommendations or RAG. I think you might have mentioned RAG. No,
Yeah.
retrieval augmented generation workflows. How about you, David? You're a lot
Yeah.
more in
No,
tune with AI than I am, so your answer is
yeah,
probably
I
going to be
mean,
more
I don't
comprehensive.
disagree with you. I think there are benefits to having both. I mean, I think it comes down to different use cases that folks are trying to handle. One of the things that I think a lot of people are not looking into or not understanding is that the scale at which you have to support vector embeddings and the scale at which you're going to read and write embeddings out of these systems is going to become pretty critical, especially when you build agentic systems. Like think about Rob making, say, one request, and that one request creates 5 agents, and like that, a million Robs exist, and that means you're talking about 5 million agents getting triggered and hitting the database. So one of the things that is important to understand is whatever AI stack you choose, including the database stack or wherever these embeddings sit, will it be scalable? Okay, and will it perform to give you the responses that you need in time? At the same time, you have to consider the resiliency piece, because the same expectations that we have today with the systems that we have built, you have to apply the same expectations to the agentic AI stack that we are building in the future. So you cannot go back in time and expect these systems to go down. So we feel like, as for us as a company, vector is a feature that we have added. It's a feature, but still the main thing we bring to the market is a highly resilient distributed database. And you can use it for SQL, you can use it for transaction. But as Rob said, depending on the use case, there is advantage to making sure when you do something, when you read an embedding out, you could always go back and figure out what is this embedding related to by running its subsequent SQL query. So I think there are advantages like that to consider.
Without any complex data pipelines to get data in from one system into another, only to then, have to munge everything back together. I think that was beautifully said. My only concern is the idea of a million Robs. That sounds horrendous.
Yeah. All right, we got another question. Thank you, Allison. Yeah, another question. Did CIDB support object PostgreSQL related data types and stuff like that? Yeah. Yeah, go
We do
ahead, Rob.
indeed.
I think you can cover that.
Yeah,
Yeah.
no. So views, functions, store procedures, triggers, they're all supported, and we are continually improving our feature parity. Under the hood, we are not Postgres. We are a distributed key value store that looks and feels like Postgres. So, yeah, but everything you expect to get from Postgres and that you already know and love, you'll get in Cockroach. If there's something that you find is missing, we can add it pretty quickly because we own all of our code and it's all purpose built to be a distributed SQL
Right.
database.
Yeah. I asked engineering once, like, how is the best way to answer this question around compatibility, right? And I think what I got to know was almost 99.9% of the features, or 99% of what you can do with Postgres, you can do with Cockroach as well. Now, how does that compare to Aurora Postgres? Obviously, Aurora PostgreSQL still has a bunch of capabilities and features missing, but Cockroach is still a little ahead of what we've done. And to what Rob said, because we built the database from scratch, we can actually add features as needed. And mostly it depends on how much a feature is requested, right? And
Yes.
so we kind of prioritize based on that. Another question that you asked, Senthil, is, hey, is there a report generation tool which helps you understand what the effort will look like? Exactly what we were answering before. We have a migration assessment tool. We call it a Molt. Molt is a suite of tools that allow you for assessing migrations and things like that. So, and then we also work with multiple partners who can provide and create these reports for you to help you understand schema and how much we need to make changes and things like that if you're moving from an existing system. Rob, I'm sure you've played around with Molt, so Molt might not be, if there are any other, you can answer that as well. So, yeah.
No, that's perfect. Yep. I think exactly the important point to mention about our Postgres compatibility is we've implemented the features that most people use most of the time.
Yeah.
So there might be a very specific Postgres extension which is supported in Postgres. Maybe it will be in the future, maybe it won't. But for the vast majority of use cases, you're not going to have a problem. And in terms of the Molt suite of tools, there's a schema conversion tool which you can feed a Postgres, MySQL, Oracle, and the like kind of schema, and will tell you if you're going to run into any complications in the migration process. Then there's Molt Fetch, which you can point to a source database, maybe Oracle, whatever the database is, with CockroachDB being a target database, and you can stream both historic data and live data into CockroachDB as part of your migration process, just to help you in your journey towards CockroachDB.
Yeah.
And then there is Molt Verify, which allows you to check that your fetch has actually worked and your data exists in both places as it should. So it's consistent and you've kind of reconciled.
Yeah. Yeah, so we'll share these details with all of you. Senthil, thanks. Yeah, so perfect. Great questions, by the way. Very good interaction.
Absolutely.
Rob, if you can go to the next slide. I mean, obviously we're coming to the end. I mean, I love to share this story because this is kind of a unique story. I mean, across the globe, different regions have different laws and rules and compliance requirements, right? If you go to Europe, you have requirements around GDPR, but that means data should not leave that particular region. Here in the US, there is this law called the Wire Act Protocol, and then especially active in use cases related to betting and gaming, where folks are like, hey, any data processed within a particular state should stay within that state, should not be processed outside. And they're talking about massive transactions across multiple regions. And so we noticed in this category, we had a customer called Hard Rock Digital. We have who wanted to expand into regions where AWS doesn't have an active region, right? Basically, say Texas or Florida, I mean, they don't have a region available there. So what they do today is they use a service that they have called AWS Outpost, which is like a big rack that you can bring in and set up within your hybrid environment, like a data center or something. And then you can run Cockroach on AWS Outpost, but yet connect it with the global cluster. And then what they do is they do data pinning to make sure that all of the data for a particular outpost region stays within that region and doesn't go. So they can still have a global cluster, but at the same time, they get the benefit of data pinning. And obviously, the benefit of that is if anything happens to that outpost region because of something, they can still access the data if they need to through the resiliency capabilities that Cockroach has built in. So there are some cool things that we do, and a lot of our customers take benefit of that. This case study is available for you to check out on our website, and we'll also send you this as a follow-up for you to kind of understand. But let's go back and just cover as we close. As I was saying, if you want to get started, we have two options. The easiest way to get started is use Cockroach Cloud, where you just have to create an account and you can choose to run, many of these three options, like that we call basic, standard, and advanced. Basic and standard are serverless options for you to kind of get started with. So you don't even have to choose your infrastructure. You can just connect your database and just start running, your read and write queries, and you should be fine. And if you have the need to like choose a particular type of compute engine, you can choose how much RAM or how much vCPUs you want in the advanced option. And if you choose to run yourself, you can choose the license, and ask us for cookbooks. If you want to get started, we'll provide that to you to easily get started on AWS with the self-hosted option. So these are two ways to get started. Would love for you guys to go try out Cockroach Cloud and see the serverless option and see how it feels. But let us know what you're familiar with. If you can go to the next slide as we close,
Yes, absolutely.
I think this is how we want to leave you with, right? We want you to think about what you're building today and think resiliency differently, right? And because Cockroach offers resilience in a different way, we are talking about multiple tiers of resiliency options, right? So if you want to cover for software bugs, disk issues, network issues, security issues, hardware failures, all these kind of scenarios, you can cover about 99.9% of that by running it on multiple different, machines, like in a single region. You can also cover for data center outages. But I think what we are talking about is covering you for scenarios where a single region is not available. So if you are familiar with what has happened this year, we had all three cloud providers had an outage. Azure had an outage, Google had an outage, even AWS had. The recent one is the US East one outage that happened, and we know how much it affected folks who were running on US East one. However, interestingly, all of our customers who ran US East one in a multi-region fashion did not have any outage. And in fact, our VP of product Jordan had shared a chat with me showing how great everything looks like, and we were bragging about it. But the idea is, if you want that level of resilience when an entire region goes down, which is now becoming more and more common, you want to cover for scenarios like that. Cockroach is the right solution. But in fact, if you want to take it to the next level, you want to cover for a cloud outage. If your goal is the cloud provider goes down between, say, Europe and the US, the internet line is cut off. Something happens that you should still be able to run your systems. You want to consider using CockroachDB. So there are all these different levels of resiliency options available to you, and we really want you to think about resilience differently, and that's what Cockroach kind of offers. So with that, we are getting to the close. If you want to get started, scan this QR code, or take a screenshot and then scan it later, whichever you prefer. I will give you $400 worth of free credits on Cockroach Cloud to get started, and we would love to learn a little bit more about what you do and how we can help. Rob is our technical evangelist, so feel free to hit him up, and he'll be able to answer questions and help you with whoever you need to talk to in different regions of our team. Hit me up if you have any AWS related questions. I work with a partner team and always happy to help you guys out. And we have a bunch of questions piling in and coming in. So,
We
Rob,
do.
let's answer
So
that
we're
too. So, yeah.
absolutely. I don't have a hard stop, so I'm happy to answer questions until I'm blue in the face. But if you do have to drop, thank you all so much for joining. But David, if you're able to, David, we'll
Yeah, I can
we'll
stick
we'll
around.
hang we'll
Yeah.
hang in there and field your questions. So thank you. Keep them coming in. So uh, so Pavel asks, okay, Molt, which sources and directions? So we can go bi-directionally. So if you want to migrate just to CockroachDB, you can fetch in that direction. You can also go in the opposite direction as well, if that's part of, let's say, a migration failback kind of scenario. In terms of sources, we support MySQL, Postgres, Oracle at the moment, but there are other databases in the pipeline. Have I missed any databases?
Yeah, no, I think those are the three. If you are running any other database, Molt is not the only option we have, right? We work with partners. If you're looking to migrate from Sybase or ADB or any other legacy system, we do have multiple, partners we work with who have suite of tools available who can help you with migration as well.
Lovely, thank you. And then Suresh asks, do you have use cases or white papers on Oracle migrations? We do. I don't know if there's a step-by-step white paper. I've certainly done a step-by-step video demo for an Oracle migration, and probably other and both MySQL and Postgres migrations as well. But we do have Oracle white papers. I think if you Google for CockroachDB and white papers, you'll probably be sent to a page full of white papers. And then Pavel also asks, we're talking about ranges now, I think. Scenario is over a single or regional infrastructure, same environment, same cloud. But
Yeah.
how will the performance be when you've got a mix of Dockerized on-prem and cloud?
Yeah, I can answer that if you want. Get started
Yeah.
with. So typically, Pavel, we recommend everyone to basically have the same type of servers or the same type of instances. So say if you're running on-prem or on cloud, we would recommend you to use the same type of infrastructure. So 8 vCPU, 16 gigs of RAM, commodity infrastructure across these, and that basically helps these systems to have the same kind of compute engine required to kind of rebalance and do the things that it needs to do. So typically that's what we offer. When it comes to performance, you also have to consider the latency that comes. So when you keep, I mean, and this is the speed of light problem, right? If you keep all your nodes and servers in a single region, in a single availability zone, the distance we are talking is basically miles, right? But you go into a multi-availability zone, you're talking about hundreds of miles, right? And then when you go across multiple regions, you're talking about thousands of miles. And then across multiple clouds, you're talking about longer distances. So obviously there will be performance hits when you run a distributed system, right? But that is tunable. That means, and how that really works is you basically want, if you have a requirement to make sure latencies are low for your users, we recommend using higher replication strategies, right? So you can basically keep higher copies of the data in the cluster, and make sure that more copies are available close to the users. That's why when you do consensus, you can basically have consensus faster between the copies of the data in the same region, and you can reduce latency. But you have to consider performance as you build a distributed system that serves a global user base. So obviously there is a hit, and we can talk more about it. It's a very good question, and if you've understood this, or if you've asked this question, then Rob has achieved his outcome today, is what I would say. All right,
I
so
think that was a beautiful answer. I think, in addition to that, what I learned from, I wrote an O'Reilly report a while back with Cockroach Labs called Understanding Multi-Region Application Architecture. And people will rightly say, if I'm just talking to a single instance of Postgres and I'm quite co-located to it, I might be looking at high microseconds worth of latency versus a distributed SQL database, which might offer low millisecond latencies. Now, there might be a performance disparity at a request level there, but when it comes to scaling, you can scale much, much higher if you're scaling horizontally, especially if you've taken out the complexity of manual sharding.
yeah.
And should we do one more question?
Yeah, I think that's the last question that Suresh has asked, basically with respect to a comparison between Oracle and CockroachDB. So,
Yep. We do, yes. I think if you go to cockroachlabs.com/compare, we've got a breakdown of CockroachDB versus a number of other databases. But what I would say on Oracle and MySQL is they are quite different databases compared to CockroachDB. So if you're talking about DB links and synonyms and rack and things like that, while there might be analogous functionality in CockroachDB, it will be a bit different. So the distance between an Oracle database and CockroachDB will be further than a Postgres database in CockroachDB, naturally.
yeah. Well said, Rob. Yeah, and I think there are considerations, right? Like many times, I mean, this is just my opinion, is that we when we are trying to compare technologies, we try to go for this apples to apples conversation. Hey, do I have this feature in this? Do I have this feature in this particular? But we forget the fact that when you actually try to apply these technologies in your use case, you will unlock new ways to do things for your application level. So what happens is many times I've seen that folks are like, hey, I want this kind of stored procedure capability in Cockroach. We're like, great, we'll add stored procedures. So you have stored procedure support now. But within a few months, you start realizing, well, I'm anyways re-architecting my application. I don't need stored procedures anymore maybe I need to like change the way I do things. So I would say comparisons are great. And obviously, we are in the market where we have a bunch of different databases to help people differentiate with. But I think the most important thing for you to consider is if you are choosing CockroachDB, what is it that you're trying to build, and how is it that we help you solve the problem? And is this particular feature as important and as much of a blocker that stops you from building the next best thing, right? So I think that's how I kind of would leave it. But yeah, what Rob said, go to cockroachlabs.com/compare, and there are a bunch of comparisons available. But if you want to learn more, hit Rob, hit my team, hit the Cockroach Labs team, and we'll walk with you to kind of help you overcome whatever you're trying to do. So hopefully that helps.
That
Um,
was perfect. Thank you. Thank you very much for joining, David. Thank you for sharing all of your wisdom. Thank you to everyone who's joined us today. It's been lovely speaking with you, if it was just unidirectional. Take care of yourselves. Have wonderful Christmases and holiday seasons. And we'll see you in the new year, where we'll be talking about we'll be comparing the differences between CockroachDB and AWS's own DSQL. So we'll hope to see you at that one. Take care.
all right.